Okay, today I am out, so I'm going to go through the notes with you on this video, and you can fill them in and do the homework, and then I will be back on Monday to answer any questions on section 1.8 and also to get started on our review for the test that's going to be Wednesday or Thursday. So this is section 1.8, and luckily it is a section that you guys should be familiar with because it's perimeter, circumference, and area of polygons. So the first blank that we need to fill in is going to be polygon. So we want to say that a polygon is a closed figure formed by 3 or more segments or sides. Okay, so if you look down, we're going to talk about the different, we've got pictures. This is a polygon. Of course, this is not a polygon because it's closed, and this is not a polygon because the two sides intersect. Just as a source of vocabulary, we have two types of polygons that we want to identify. One is the convex polygon, and that's where all the diagonals, and diagonals, of course, are lines that connect two vertices that are not side by side. All the diagonals are inside of a convex polygon, and one or more diagonals that are outside of a polygon gives you the concave polygon. So those are two examples of that. The next vocabulary word is perimeter. Again, the perimeter is the sum of all sides of a polygon, so we would just add up all the sides for that one. Area is defined as the number of square units enclosed within the polygon. And then circumference is the distance around the circle. And again, circumference is kind of like perimeter of a circle. Circles can't have perimeter because they don't have sides, but we do have a circumference. And then we're going to talk about this in a minute, but the circumference is found by either 2 times pi times the radius, or pi times the diameter. Okay. Now at any time, if I go too fast or too slow on this video, feel free to stop, pause, and then you can pick up with me. All right, so the next fill-in that you should have is this graphic right here. The first one is a square, and we know a square has 4 sides of all equal length and 4 right angles. To find perimeter, we would either add up all 4 sides, or we could, since they're all the same, multiply by 4. To find the area, we would multiply side times side. For the triangle, we would add up side A plus side B plus side C. And for the area, we would do 1/2 base times height. And remember, height is the altitude. It goes from one vertices to the opposite side, forming a right angle. So notice that sometimes with triangles, the altitude is actually outside of the triangle, depending on how it's drawn. So we just have to pay attention to that. And I know you've seen those before. For the rectangle, again, 4 sides, 4 right angles, but not 4 congruent sides. So for the perimeter, we can either add up base plus height plus base plus height, or we could say 2 times the base plus 2 times the height. And then for the area, again, it would be base times height. For the circle, notice the diameter goes all the way side to side through the center, and the radius only goes from the center to the side. So the radius is actually equal to half of the diameter. So for circumference, which is the distance around, we're either going to use pi times diameter, or we're going to say 2 times pi times the radius. Okay, and then for the area, we're going to use pi times r squared. Okay, and then in case we've forgotten, we just want to make sure that we remember that the diameter is equal to 2 times the radius. Okay. All right, let's try the first example. The Botany Club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside path. How much edging material will they need? Okay, so they want to put edging right here on this outside, and they need to know how much edging material they're going to use. Okay, so it looks like this is asking for area of this section right here, going all the way around. So in order to do that, we're going to need to find area of the larger rectangle, right? And then subtract the area of the smaller rectangle. And that should give us the area of um, the edging, which is around here. Yeah? Okay. So the smaller rectangle is going to be 16 by 22. So we know this is going to be subtracting 16 feet by 22 feet. Okay. Now for this larger one, we're actually going to have to add to 22 4 feet at the top and 4 feet at the bottom. So this one will be 22 plus 8, right? And then we're going to have to multiply that times, and then this 16 will also have to get the 4 feet here and the 4 feet here. So we'll say 16 and 4 is 20, so we'll say 16 plus 8. Okay? And then that should give us the area that we're looking for, which would be the area of the edging. Okay? So let's go back and let's look and see what these numbers actually become. So 22 plus 8 is going to give me 30. So that's 30 times, and then 16 plus 8 is going to give me 24. Okay, so that's going to give me my first area. And then again, we're going to subtract 16 feet times 22 feet for that. Okay, alrighty, so let's see what this becomes. And grab my calculator and punch these numbers in. And first I'll have 30 times 24, and that will give me 720. And again, this is going to be feet squared minus 16 times 22, and that will give me 352 feet squared. Okay, so then I will take 720 and subtract 352, and it looks like we're going to need 368 square feet of edging. To cover that area around. Okay. All right. Next thing we need to talk about is what is pi. Pi is a ratio of circumference to diameter. It's represented as 3.14 or 22 over 7, and it's used in calculating area and circumference for circles. Okay, so let's go ahead and use it to calculate. Remember that we said that the circumference is going to be equal to either 2 pi r or pi d, and we said that area of a circle is going to be pi r squared. Okay, so if I look at this circle right here, it says first, what is the circumference in terms of pi? Okay, so in terms of pi means that I don't actually multiply pi, I use the pi symbol. So if I'm looking for circumference, the diameter for this is equal to 15. So I'd say circumference is equal to 15 pi. Okay, and since it asks for in terms of pi, I would actually say 15 pi. So the answer would be 15 pi inches. Okay, and that's linear, so it would not be square. The next part says to do it in to the nearest tenth. When I do it to the nearest tenth, I'm actually going to multiply 3.14. So for that one, I'm going to say 15 times 3.14, and I get 47.1. So for this, I would say that circumference is about equal to 47.1 inches. And I'm going to use about equals because now I have multiplied pi, and pi is an irrational number, so it's been rounded. So I need to use that equal sign for that. And then the next thing I want to talk about is when I have the radius. And again, for this one, I'll use the 2 pi r. So circumference is equal to 2 pi r. So circumference is equal to 2 pi times 4. Now, in terms of pi, circumference is going to be 8 pi centimeters. Okay, but then rounded, the approximate, rounded to the 10th, is going to be 8 times 3.14, and that will give me 25.12 centimeters. And again, since pi is an irrational number, it's approximated, and we'll need to use the about equal to for that one. Okay. Now, for this one, we want to say what is the perimeter of this triangle. And for perimeter, we need the distance for the sides. So if we look at the two horizontal and vertical sides, then we know that the distance can just be counted, or we could use, you know, GF is equal to the absolute value. We know that -2 doesn't change, so we would just say -3 minus 3 for that. And then for EF, we could say the same thing. We know that 3 doesn't change, so it would just be equal to the absolute value of 6 minus -2. Okay, and those would be fairly simple. So we'd say GF is going to be -3 minus 3 will give me -6. Absolute value is 6. And 6 plus 2, this is going to give me 8 for that. Now, the next thing I need to do is find the distance for this side right here that is not where both x and y are changing. So for that, I can use the distance formula. Remember, the distance formula is the square root of, and I would say x2 minus x1 squared, right, plus y2 minus y1 squared. Okay, so the distance is EG. So we can substitute EG for D, and then I can substitute the values for x and y. So the x for E is going to be 3, and the x for G is going to be -3, and we're going to square that. Y for E is going to be 6, and the y for G is going to be -2, and we want to square that. So moving down, -3 minus 3, that's going to give me 6 squared, and this is going to give me 8 squared, and that is 36 plus 64, and that gives me 100, which gives me 10. So EG will be 10. Now we got to remember that we actually want to know perimeter. So if I go back, I can say P is going to now be equal to 6. So we say 6 units plus 8. So plus 8 units plus 10. So 10 units. So that's going to give me 6 and 8, give me 14 plus 10. That'll give me 24 units for that. And then units just because I don't have inches or uh, uh, centimeters or anything. Okay, so the next one is a poster, and we're going to design this poster 3 yards wide and 8 feet high. So I'm going to, oops, nope, not a circle, sorry. I'm going to make this poster, and I don't know exactly what the dimensions are because I have yards and feet, so I'm just going to have to kind of guess here. It says it's 3 yards wide, so that's 3 yards wide, and then it says it's 8 feet high. Okay, now I need to find out what the area is. It says how much paper will I need, but I can't do it with feet and yards. But it asked for my answer in feet, so I think I need to convert yards to feet. So I know there's 3 feet in a yard, so I'll go over here and use my dimensional analysis or unit analysis, and I'll say 3 yards over 1 times, I know yards go on the bottom here, so I have yards and I'm trying to get to feet, so that means there's 3 feet in 1 yard. So that's how I set that up. And 3 times 3 gives me 9 yards, and yards will cancel, so I have 9 feet. So 9 feet. So area will be 9 times 8, which will be 72 feet squared. 72 feet squared is my answer. Okay. The next one is finding area of the circle. So area of the circle, remember area is going to be pi r squared. And it asks for in terms of pi. So I actually can leave pi as a symbol and not multiply by 3.14. This is giving me diameter. So the diameter is equal to 16. Therefore, the radius is going to be equal to 8 because the radius is going to be half of the diameter. So the area is going to be pi times 8 squared, which is going to give me 64 pi meters squared. Okay? The next one I'm going to do is the irregular figures. So this is how do we find area of a figure that doesn't fit one of our square, rectangle, triangle patterns. So one of the easiest ways is to break it into patterns that we know, right? And so that's what I've done here is to kind of break this into here, right? And then to this rectangle, which is obviously a little bit too large, but to the rectangle, and then here. So we have 3 rectangles. So I'm going to break that out, and I'm going to find the area of each of these figures. Okay? So these little congruence marks right here will tell me that this is 3, this is 3, this one's 3, this one's 3, this one's 3, this one's 3, this is 9, and this is 9. So that helps me. So I can say, for this one we have 3 and 9. Okay. For this one, this is also 3, but this is going to be 9 minus 3. So that's going to give me 6, and this is going to give me 3 times 3. So this is going to be 3 times 3, which is 9. 6 times 3 is 18, and then 9 times 3, which is 27. So the area will equal 9 plus 18 plus 27, which will be, let's see, 27 and 27, 54, and what is it, centimeters squared, because it is area. For the last example, I'm going to break it into a triangle and a rectangle. And I'm going to use my congruence markings. So this one is 4, so that makes this one 4 right here. And this is 12, but it's going to be 12 minus 4, so that's going to make this 8 right here. Okay, so this rectangle is going to be 4 times 12, and 4 times 12 is going to give us, it's going to give us 48 feet squared. And then this is a triangle, and this is the area here is going to be equal to 1/2 base times height. So that's going to be equal to 1/2 base, which is 4, times 8. Okay, so we'll say 4 times 8 is 32, divided by 2 is 16. And so the area for this irregular shape will be 48 plus 16, which will be 64 feet squared. Okay, so go ahead and do the problems here, 7 through 22. And again, if you get stuck on any of them, circle them, star them, and I will be back on Monday for us to go over.